Good morning, this is Dr. Turner with Integrated Math 2. Today we're going to be covering 8.1, which is looking at tangents and circumscribed angles. As I mentioned before, with Integrated Math 2, with our coursework, Semester 2 of Integrated Math 2 kind of jumps a little bit all over the place. We talk a little bit about trigonometry, we talk a little bit about geometry, we talk a little bit about algebra. So it kind of jumps up all over the place. We just got done in Unit 7 introducing trigonometry. Now in Unit 8 we're going to be focusing on circles. Don't mind if it's kind of hopping around here, that's intentional. Okay, so we'll go ahead and get started here. Obviously the title of the lesson here, we're looking at circles. So the title is Tangents and Circumscribed Angles. So a couple things. In this whole section, we're going to be dealing with circles. Specifically here in 8.1, when we talk about a tangent line is going to come up in several places, but in terms of a circle, a tangent line is a line that intersects our circle at exactly one point. So right here, and it's kind of hard to see, of course, but your tangent line is only intersecting your circle at one point. That's the definition of a tangent line. Now, the other half of this title, circumscribed, that means that we're going outside of the circle. So when we look at an angle that's being circumscribed about a circle, what that means is that we are going to be drawing an angle that contains the circle like so. And it could be any sort of number of measurements here, but this would be a circumscribed angle because it's going outside of the circle. So this is our circumscribed angle. In the book, we have two particular theorems that we're going to be focusing on when it comes to tangents and circumscribed. The first is that in a diagram here, we're going to have labels. So I might call this, let's say, angle ABC. Okay. And then also with the circle, what we're going to have is an angle that's inside the circle. Any angle, we've talked about this before, but any angle that is starting at the origin of a circle with its center, its vertex at the radius, we call that a central angle. So let's call this AOC. So our first theorem is that if we draw a circumscribed angle about a triangle, the first theorem is that these two sides, AB and BC, are going to be congruent. So that's the first thing we need to know for this section. The second, our first theorem, is that the circumscribed angle and the central angle that it's intersecting are supplementary. What does that mean? That means that this angle here, ABC, and the central angle that it's intersecting, in this case AOC, those two angles are supplementary. From Integrated Math 1, remember that supplementary means that the two angles have to add up to 180 degrees. So the measure of angle ABC plus the measure of angle AOC has to equal 180 degrees. So this is the first half of your assignment, just recognizing these two facts. Now, obviously doing this on the computer, it's a little bit harder to do the diagram or illustrate as opposed to if we were doing this on paper. So in the program, in Schoology, as you guys are going through this assignment, there's a lot of stock images. So it might look like the same image. I might just copy paste this image over and over again, but I'll give you different measurements for the sides. So for instance, a problem in this section might be very simple. It might be if AB is 12 centimeters, what's BC? And I would write this out in a more complete sense, but what's the measure of side BC? So based on our theorem and based on the given information in the diagram, I know that AB and BC are congruent. So if AB is 12 centimeters, then BC is also 12 centimeters. There's no algebra to show here, it's just recognizing that those two are the same. If I tell you that AB, or the other way around, if BC is 5 inches, What's the measure of AC? Recognizing that these two segments are congruent, you would tell me also 5 inches. Okay. So that's part 1. Part 2, same diagram. We want to be able to recognize that those two angles are supplementary. Supplementary again means that my angles have to add up to 180. So if I know one of the angles, I know the other angle. So if the measure of angle ABC is, let's call it 35 degrees, what's the measure of angle AOC? Because they're supplementary, I know they have to add up to 180, so I would simply do 180 minus 35 to get that measurement, which is 145 degrees. So those should be fairly straightforward. Some questions will be that easy. Some questions will throw in a little bit of algebra to make it a little bit trickier. But it's the same concept. So for instance here, I could make number 4. If the measure of angle ABC equals 2x and the measure of angle AOC equals, let's call it 8x, solve for x. So here I'm not even given any values for the angles. However, I know that the sum has to be 180 because the relationship between those angles is supplementary. So to solve for x, I would add the two angles, 2x plus 4x, 2x plus 8x rather, equals 180. I would combine like terms and then divide by 10. So x equals 18. Usually in these types of questions, it'll be a two-parter, so it might say solve for x, and then maybe it also says, what's the measure of, say, ABC. So we have to solve for x, that's the first part, and then once we find x, we can plug it in to find either of those angles. ABC is 2x, so 2 times 18 would give me 36 degrees. Okay. So that's half of your assignment, first 6 questions or so. You need to understand what a tangent line is. You need to know what a circumscribed angle is. And then also it's going to contrast that with what's known as an inscribed angle. So an inscribed angle is an angle that is inside rather than outside the circle. So if I'm drawing an angle going from the outside of the circle, and it's contained within the circle here, then that is an inscribed angle. So inscribed is inside, circumscribed is outside. The other theorem we have in terms of supplementary angles is that when we look at a quadrilateral inside the circle. So in a quadrilateral, and this is kind of based on the circumscribed angle theorem, but if I draw two angles inside that are meeting at some point, and imagine that these are touching my circle here, but if I have two angles that are inscribed that are meeting at some point, and let's call this QRST, okay, quadrilateral QRST. Quadrilateral, of course, has 4 sides. Okay. In a quadrilateral, the two angles that are opposite each other, or the two inscribed angles, are always going to be supplementary. So in this case, angle QRS and angle QST are supplementary. So measure of angle QRS plus the measure of angle QST. Those angles are supplementary, which means they add up to 180 degrees. So given one angle, I should be able to solve for the other. It's going to look very similar to 1 through 4. So number 5, if I say the measure of angle QRS is 70 degrees, I tell you to find the measure of angle QST. And that's just subtracting it from 180. 180 minus 70 gives me a measurement of 110. And just like in number 4, I could make this a little more complicated. You could throw in a little bit of algebra there. So If the measure of angle QRS is 2x, and the measure of angle QTS is 3x, solve for x. Remember, in any diagram, you're always going by the given information, not by what it looks like. So same thing here, just like we did in number 4, you'll add them up, equal to 180 degrees. Combine like terms, and then you'll divide 180 divided by 5. We end up with 36. That's it for today, guys. If you have any questions, please reach out to me or attend during office hours. Otherwise, have a good day. I will talk to you soon. Bye.